SQA Advanced Higher Maths 2018, question number 17. This is the last question of the 2018 paper, part A. Given that f of x is equal to e to the 2x, obtain the MacLaurin expansion for f of x up to and including the term in x cubed. This is for 2 marks. If you work out, write down the ex, MacLaurin expansion for ex first. X to the 0 over 0 factorial plus 1 times x to the 1 over 1 factorial plus 1 times x squared over 2 factorial plus 1 times x cubed over 3 factorial, which means that e to the x is 1 plus x plus a half x squared plus 1 over 6 x cubed, which then means that e to the 2x is equal to, just replace the x's by 2x, 1 plus 2x plus 2x squared over 2 plus 2x cubed over 6. E to the 2x is 1 plus 2x, 4x squared divided by 2 is plus 2x squared. This is going to be 8x cubed divided by 6 is equal to 4 over 3x cubed. That is e to the 2x. And then for B, part 1. On a suitable domain, let g of x equal tan x, g of x is equal to tan x. Show that the third derivative of g of x is given by this. Third derivative g dashed of x is equal to 2 sec to the 4x plus 4 tan squared x sec squared x. This is for 3 marks. So g of 0 is equal to, g of x is tan x. G of x is tan x. G of x is tan x. G dashed of x is sec squared x. G double dashed of x is 2 sec x, and the differential of sec x is sec x tan x, which is equal to 2 sec squared x tan x. And now you're going to differentiate. This is your third derivative. So you bring this to the front. This gives you 4 sec x. And then the differential of sec x again is sec x tan x. And you've already got the tan x there. Plus, leave the 2 sec squared x as it is. And the derivative of tan x is sec squared x. So you're ending up with, this is your 2 sec to the 4x to the 4x plus 4 sec squared x tan squared x is required. And that's for 3 marks. Okay, then. Hence obtain the MacLaurin expansion G up to including the. Okay, hence obtain the MacLaurin expansion of G of x up to and including the term in x cubed. Okay, this is the second part. So G of 0 is equal to 0. G dashed of 0 is equal to 1. G double dashed of 0 is equal to 0 again. And G triple dashed of 0 is equal to 2. That implies what you've got there is 0 x to the 0 over 0 factorial plus 1 x to the 1 over 1 factorial plus 2x cubed over 3 factorial, which means this is just 1, which is just x, and the 2 divides out with that 2 plus 1/3 x cubed. So this is what g of x is. That's the second part of B. Then you go to C. Hence or otherwise obtain the MacLaurin expansion of e to the 2x tan x up to including the term x cubed, and this is for 2 marks. Okay, so hence or otherwise obtain the MacLaurin expansion of e to the 2x. So e to the 2x tan x is equal to e to the 2x, you've got there 1 plus 2x plus 2x squared plus 4/3 x cubed. Okay, and tan x, you got x plus 1/3 x cubed. Multiplying these out, 1 times that gives you x plus 1/3 x cubed. 2x times this gives you 2x squared, 2x squared, and that is going to give you 2x to the 4, so that's no use. And then 2x times that gives you, and 2x squared times this gives you plus 2x cubed. 2x squared times the next gives you your term x to the 5, that's no use. Adding these up, you got x plus 2x squared plus 2x cubed plus 1/3. This is 6 over 3 plus 1 over 3 plus 7 over 3 x cubed. That is part C. And part C is for 2 marks. Now you're on to the last part, D. D. Write down the first 3 non-zero terms in the MacLaurin expansion of 2e to the 2x tan x plus e to the 2x sec squared x. So that is just the differential of this would give you what they've got there. So that means that 2e to the 2x tan x plus e to the 2x sec squared x is equal to the differential of this, which is 1 plus 4x, bring the 3 to the front, plus 7x squared, and that is for 1 mark. That is question 17, the last question of 2018 paper.